Hey everybody, welcome back. Service Provider Architecture Overview, Part 2. I want to stay vendor neutral, continuing in the same vein as the first video that I did. These overarching concepts are true no matter what vendor you're working with. Okay, so I know we're itching to get on the command line or understand how to implement service provider architectures in Junos or in Cisco's iOS XR or iOS XE, and that time is coming. But let's lay the foundation. Let's get some concepts in place first before we get down in the weeds on implementation. Okay, so looking back at the overview, I want to talk about connections in a service provider network. So let's just draw a few routers here. We have a service provider network in the middle. We have a service provider over here, a neighboring telco or a neighboring ISP, and a service provider over here. All right, I can draw a cloud around each provider so that we can see the difference. Provider SP1, SP2, SP3. And when you connect to another provider, this is known as an external network to network interface. Okay? There's another one right there. An external network to network interface. All right, so you'll set up agreements with neighboring telcos because you have business in that area or a customer in that area that needs to be reached. And so you'll enter into an agreement with a neighboring service provider of where you can strategically connect your routers with a 1 gig connection, a 10 gig, 100 gig, whatever makes sense for the business opportunities that you all share. Okay, everybody's going to get paid for the service that's provided to the customer. Everybody will get a cut of it, and that'll be part of the agreement. You'll even enter into an inter-NOC agreement, an agreement between your network operations centers, so that there are correct escalation methods whenever you're troubleshooting circuits or handing off or trying to find out where a problem is. You're going to be working together or alerting each other of the fact that there's a problem. So you'll have to enter into a relationship with these neighboring telcos. It's very interesting how you make all this Metro Ethernet or Carrier Ethernet work. But it's all because there's a customer over here. Let's say customer site 2, and let's say customer site 1. Okay, and so when the customer connects to a service provider, that connection is called a user to network interface. That's a uni connection. All right. So what we have here is we have a customer in 2 different geographically dispersed locations, and that customer doesn't have connectivity to one and only one provider. That customer has connectivity to service provider 2 over here. They have connectivity to service provider 3 over here, and those 2 service providers don't even connect. They have to go through an intermediary service provider. All right, so see what's going on here? There's a bit of coordination that's going to need to be involved to make this Ethernet circuit work. Now, this is a lot of MEF speak, Metro Ethernet Forum terminology. There's a lot that goes into becoming Metro Ethernet Forum certified, and a lot of it is most of it, all of it is vendor neutral. Okay, so that's why I'm trying to stay general. Now, one of those concepts that's important to grasp is the idea of a service provider of record. Who does the customer call to order this service? Okay, and that is also the service provider that they pay for the service. Let's just say that service provider 1 happens to be the service provider of record that is on the hook to provide this circuit to the customer. All right? Now, service provider 1 knows that they don't have connectivity to physically connect to these two customer sites. However, service provider 1 has already sought out or immediately seeks out neighboring SPs or neighboring telcos that they can connect to so that they can reach this customer. All right? So this is what I talked about with the internock agreement and the relationship that you will enter into with your neighboring telcos so that you can accomplish this business. Now, another concept that needs to be understood is these service providers, in the overall scheme of things, become known as operators. So you have operator, network operator 1, I'll just say operator OP1, and the SP in the middle is also known as an operator. So you have OP2, and then you have operator network 3. Okay? So this service provider, I'd like to throw a concept out there real quick. The overall service provider of record actually doesn't even have to own any networking equipment. All right? They simply can just reach out. They can be a Ethernet service provider without even owning any equipment. They can just contract with operator networks to provide this service and then contact the customer and say, okay, the circuit's ready, go forth and network, go forth and pass traffic between your two sites. So this service provider can own a network or it doesn't necessarily have to. But let's just say in this case it does, but it's still a piece of the operator cloud. So there's multiple operator networks involved, operator 1, operator 2, and operator 3. And you know what? Just to stay consistent with my numbering, let's just call this operator 2 and this operator 1 so that our numbers, there's OCD kicking in, so we keep our numbers the same. All right, now, another concept is the overall circuit. Here, you know what? I'm going to use a different color. The overall circuit end to end between this router and this router is known as an EVC, Ethernet Virtual Connection. All right, the overall circuit end to end is known as an EVC. When we are all said and done, this layer 2 service, if the customer was to diagram their router architecture or their layer 3 picture, it would look like this. One router hop, second router hop. That is one long data link there. All right, this is simply a carrier Ethernet, metro, wide area Ethernet connection, bridged. Okay, it's incredible that we're bridging this all the way through, but we are. Which brings up a point. A lot of people are very scared of doing bridged Ethernet over the wide area, but it's here to stay. It's a service that's out there. There's an entire consortium. I've made mention of it over and over again, the Metro Ethernet Forum, that is furthering the acceleration of carrier-grade Ethernet and have been for many years, and that's what it's about. I'll just name a few business cases. Cellular backhaul, huge. A lot of your big cellular providers are contracting with telcos, incumbent local area exchange carriers, LECs, and these LECs, these telcos, these service providers are doing exactly what I'm talking about. They're entering into these multi SP agreements so that they can pass this traffic. So I'll just speak a little bit more about that. Cellular backhaul, your big macro cell towers that the antennas are on to provide 4G and 5G cellular is bridged Ethernet from the tower to what's known as a MITSO, a mobile switching center, MTSO. And so we take a VLAN. If this was a tower, you take in a VLAN number and you carry it through multiple providers and you pop it off at a backbone switching center. All right. So cell backhaul, CBH, huge reason for bridged Ethernet through the wide area. Wholesale Ethernet, business Ethernet. That's another one. School districts. That's another one. A lot of school districts want their schools connected to their headquarters or their administrative office, and they want it at layer 2. Municipalities, city hall, fire department, police department, the water utility, electric companies. They they want their bridged Ethernet. They want their sites to appear as layer 2. Okay, so as a service provider, you just need to know what you're doing. You need to know how to configure these, and I'll plug MEF once again. E-line, E-LAN, E-tree, and all the variants thereof are point-to-point, routed multi-point, and multi-point to multi-point. For a LAN-like environment, multi-point is E-LAN, and we'll get into those later in detail, but I just want to throw out an overview here and speak to a lot of this. So layer 2, here to stay. And so end-to-end Ethernet virtual connection, the EVC, is the end-to-end circuit. Now, each piece of that circuit has to go through 3 providers. Those pieces that make up this overall EVC, let me move my uni tag here, or my uni label. Each piece that makes up this overall EVC within the operator cloud is known as an OVC. Operator virtual connection, OVC number 2, operator virtual connection number 1, operator virtual connection number 3. So it takes all those OVCs to make up the totality of the EVC. All right? And you're going to be working with these telcos will agree, how are we going to pass this Ethernet across here? Absolutely, it's going to be tagged. You're absolutely tagging Ethernet at this ENNI. Okay? The MEF specs out that it will be in the form of provider bridging, 802.1 AD. I'll tell you, it's really up to the 2 providers whether or not they do that. In my experience, it's been 802.1Q. It's VLAN tagged nonetheless, but that's the difference between implementation and what providers are willing to do and comfortable at doing, and what a overall consortium or standards body says is recommended. So there's recommendations and then there's real world. And so this is the recommendation, 802.1 AD tagging, but you'll find that a lot of providers are using 802.1Q. At the uni, you could take in untagged Ethernet frames on a port-based MEF service, or you can take in VLAN tags as a VLAN-based service. There's things called bundling, there's things called service multiplexing. We can get into details on that later. But so at the uni, it can be tagged or untagged. All right? And you may even agree as a provider that there's a carrier tag, a stacking of tags of sorts on how you will transit a provider's cloud to reach customers. All right? So there's a good bit of inter-engineering group interaction that takes place in setting this up, laying the foundation so that subsequent orders go smoother. All right? So that is some of the moving parts of layer 2 in the service provider. I'm looking at my list of topics here. Let me swing that over. And yeah, just want to mention, this ain't your enterprise Ethernet anymore. 4096 isn't necessarily a limit anymore. It's absolutely not a limit anymore. You know, back in the day, there was a 4096 limit of an enterprise switched Ethernet that VLAN trunking protocol, your VTP client and server process kept track of all your VLANs, and they had to be consistent. And it just kept track of all that for you. Well, VTP typically doesn't run on service provider grade gear. And really what's going on is you're pushing and popping tags. You are, say for instance, a cell tower or this customer, this business Ethernet, wholesale Ethernet customer says, we agree, we're going to pass traffic on VLAN 10. As a provider, I might decide to pop off VLAN 10 as it comes in and pass that across my service provider network as 100, and then tell this service provider, hey, be prepared to receive that as 100. And then they can push it or pop it, carry it across their cloud. Basically, We just need to deliver it to the customer over here as VLAN 10. Okay, so really the significance of the VLAN in the service provider network starts and stops right there at the edge of where the service provider and the customer agree on the VLAN. And also at this ENNI, you're going to want to, your significance can start and stop right there. But as far as what you do in your cloud, you can do whatever you need to do inside here as long as it complies with some kind of agreement that you have with the other provider or the customer. All right. So, the point is that if you had another customer router hanging off, let's say right here, well, they could use VLAN 10 over here and you could pop it off, carry it across your core as a different VLAN number, and then push it back on as you connect to this customer over here as VLAN 10. So as long as you keep these circuits separate, all right, and you'll configure this is customer, this was a separate customer than that one, then you're going through a complete, you're going through a routed architecture perhaps that's got BGP, MPLS services sitting on top of it, or it could be G.8032, but whatever means that you use to accomplish your service provider layer 2 bridging, as long as you keep it separate, then you can use a whole different set of VLANs as it pertains to this customer than you are for this customer. All right, so I think that is about as much as I wanted to cover for layer 2 service provider architecture high level concepts. All right, okay, so layer 3 concepts in service provider networks. So take that same service provider 1, got some routers in here. We got the internet, of course, we're going to be connected to the internet. When you connect to the internet, this is typically known as a drain, an internet drain, or it's also called an internet transit connection. Oops. Transit connection. Okay. This would, the way that this provider is sitting currently looks like this could be known as a multi-homed non-transit AS. So multi-homed non-transit autonomous system. So let's just say the AS number of this service provider is autonomous system number 123, and you will register your autonomous system number with the American Registry for Internet Numbers, or RIPE if you're in Europe, or wherever you are in the world. You'll get a registered autonomous system number. This is how BGP sees you. This is how BGP sees this network. I don't care how detailed this network is or how complicated with various routers in here. This network looks like one hop to BGP in its AS path list. That's an attribute of BGP. We're going to get into detail in BGP when we get into the concepts as they relate to BGP and how it advertises reachability information. Okay, and so if there's no other providers hanging off of it, in the internet world, this would be multi-homed, non-transit. There's no traffic going through it. Okay, you would not want traffic to come in and go back out. So you would, your routing advertisements would disallow such things to occur from the upstream provider's perspective, as well as yours. You would not allow transit traffic to come in one connection and go out another one if in fact you are a non-transit AS. Okay? So something else going on in service providers these days is the concept of CDNs, content delivery networks. We are seeing in a great deal of servers being deployed in local service provider networks where you have eyeballs, where you have closest to the end user. An eyeballs network is the users that are using their computers for business, education, entertainment, whatever. They are your eyeballs. A service provider doesn't necessarily have to have eyeballs in order to be in business. They could be a transit provider providing backbone internet services to other service providers or to other just huge companies for whatever reason. But your residential and broadband internet providers are the eyeball providers to those folks using their computers at their homes. So let's just say, for instance, this service provider in the middle has 100,000 customers. Well, these content providers, these large content providers in the world, are monitoring where this traffic is coming from. And these content providers are seeing this traffic come from autonomous system 123. And these content providers reach out to service provider 1 and say, hey, we would like to send you some high capacity servers that we put our it's a cache. It's a local cache. The concept of a cache is a place to store something that's more readily available. It's really the concept of a convenience store. Okay, your convenience store has milk and eggs. It has stuff. It has staple items. It has stuff that people use more often. Okay, and so these content providers in the world, you can imagine who they are. Large content providers of video streaming services and content and social media platforms and things like that are reaching out to providers and saying, hey, we're seeing whatever the threshold is that they deem necessary before they'll put a local cache here. We're seeing that amount of traffic come from your AS 123. We would like to send you some high capacity servers. And so whether it's 5 gigabits per second at peak utilization time or 10 gig or whatever it is, and they'll put those servers out there. Now, what I wanted to tell you about that is, if this is CDN provider 1, we'll call it, I'm trying to keep it generic, then this is a ebgp connection. They physically connect these servers into the provider's edge, okay, into SP1's PE, into the provider edge router here, and this is AS 1, 2, 3, 4, 5. Okay, and this is an ebgp connection. Okay, this CDN might be directly connecting these two servers, or this CDN provider might have a router in between here. They might have a router in between there where they have the servers connected to the router, and then the router has one connection, in which case this provider is probably ebgping with the router. But in other cases, inside this AS, there's a virtual IP. I'll just draw it inside of here, a virtual IP, and there's the ebgp neighbor session is to the virtual IP that is formed inside of this cluster, okay, inside of that content delivery network cluster. Now as you can imagine, these, I'll draw it in red. These customers down here, when they go to www.whatever, their request is serviced right out of those caches, okay? That massive download traffic is now coming right out of yours truly, these local caches. And look up here. Look where we're saving bandwidth. We're saving bandwidth over these precious, expensive internet connections, and we're no longer, when you're monitoring your internet connections, you'll see the utilization drop way down when you get these content delivery network caches in place. All right. So another thing, you'll wanting to be monitoring your internet connections with netflow so that you can see exactly what's going on in your network. It'll help with ascertaining the causes of distributed denial of service attacks. It just helps all around with understanding what the prominent type of uses of your internet connections are, and things like that. Okay, so I'll also add this, that the EBGP neighborship here obviously is not for your traditional reachability. Okay, I'm not learning EBGP routes as a provider. I don't learn routes over this connection. As a matter of fact, I don't want to learn any routes. Why? Because I don't need to transit this to IP addresses back here. Okay, I need to send my routes to these caches so that the caches know who to cache out information for. All right, you don't want these caches providing services to IP addresses up here in SP number 2. You're doing it for SP number 1. Now you could expand on this architecture, and these CDNs usually allow for that. But in the simplest of cases, your IP space that's in your network is what you're going to advertise towards these CDNs so that they know what traffic to subsequently cache out and send out that content for. All right. So I think this is about all that I wanted to cover. Oh, there's another concept of peering. Some service providers will go to a large city in a data center somewhere, and they'll peer with one another. I've never been experienced with peering myself, but I understand it's a place where you can exchange routes and exchange data at a high capacity aggregation point where a lot of providers will peer with one another and exchange offload traffic from transit connections that way. You can even reach some CDNs in locations like that as well. Okay, so hey, so this is it for the overarching concepts of service provider architectures. I hope this is informative to you. Subscribe, like this, share it with others. Give me a comment if there's something else that you'd like to hear about. And till next time, thank you.